Okay, think about the last meme you saw or shared. Now, what if I told you that funny cat picture could actually be a Trojan horse? That's what we're talking about today, digital steganography. It's the wild art of hiding secrets right out in the open. I mean, seriously, we all do it, right? We download and share tons of images every single day without a second thought. But that simple act, it could be the wide open door for a really nasty malware attack. And I'm not talking about some sci-fi movie plot. This stuff is real and it's happening as we speak. Okay, so before we get any deeper, we've got to clear something up. It's super important. You've probably heard of cryptography, right? That's like putting a message in a locked box. You see the box, you know something's inside, but good luck opening it without the key. Steganography? Totally different ballgame. It's not about locking the box, it's about making the box itself completely invisible. The whole point isn't to scramble the message, but to make you not even realize there is a message. And you might think this is some high-tech modern problem, but believe it or not, the art of covered writing is literally ancient. Let's take a quick look at how this old trick got a brand new powerful life online. Yeah, check this out. The ancient historian Herodotus talked about this stuff. He described spies carving secret warnings about an invasion into a wooden tablet, and then just covering the whole thing with wax to make it look blank. Or even wilder, tattooing a message on a messenger's shaved head, and then waiting for the hair to grow back to hide it. The basic idea is exactly the same today, but the scale, it's just staggering. Instead of one person's head, hackers now have billions of photos and videos being uploaded every single day to use as their hiding spots. So how in the world do they actually do it? How do you hide a whole virus inside a picture? Well, it all comes down to messing with the tiny little dots, the pixels, that make up the image itself. What's wild is how simple the core idea really is. See, every single pixel on your screen has a color, and that color is represented by a string of ones and zeros, binary code. Now look at these two binary numbers. To a computer, they're obviously different. One ends in a 0, the other in a 1. But for you and me, to our eyes, the change in color that this represents is so tiny, so microscopic, you would literally never ever notice it. And that one single invisible change, that's the whole secret. This whole process has a name. It's called least significant bit insertion, or LSB for short. And here's how it works. A hacker takes that very last digit of a pixel's color code, the least significant bit, and swaps it out with one bit from their secret file, just one. Then they move to the next pixel and do it again and again and again, thousands, maybe even millions of times, until bit by bit, they've woven an entire secret file right into the fabric of the image. And trust me, it gets way more advanced than just fiddling with pixels. There are methods like transform domain techniques, which is a fancy way of saying they hide the data not in the color you see, but in the complex math behind the image's frequencies. Think of it like hiding a single, quiet whisper inside a loud, complex musical chord. You'd never hear it. And they can do the same thing with sound files, with video, which just opens up a massive amount of space to hide things. Okay, so we know how it works, but how does this all turn into a weapon? Let's get into the why, how this is used to slip malware right past all our digital security. So here is the typical playbook. Your firewall, your antivirus software, they're trained to look for dangerous programs, right? Not harmless picture files. So that JPEG of a sunset, it just sails right on through. But once it's on your computer, a tiny, harmless-looking script gets triggered. And this script's only job is to go to that safe image, read the pixels, and start pulling out all those hidden bits of data one by one. It then stitches them back together into the real malware, right inside your computer's memory, where it's much harder to spot. And look, this is not a what-if scenario. This is happening out in the wild. The Dakua malware, which was related to the famous Stuxnet, used this exact technique. For years, it was stealing data from industrial systems and sneaking it out, hidden inside perfectly normal-looking image files. And then there was Stegaloader, which hid its entire malicious brain inside a generic PNG wallpaper file. It could just sit on your desktop, completely invisible to normal security scans. But maybe the cleverest and scariest use is for what's called command and control. See, normally malware has to phone home to a server to get new instructions, and that server can be found and blocked. But with steganography, the malware can just be told to say, check a specific public Twitter feed or a random forum. The hacker then just uploads a new meme. The malware on thousands of computers downloads that innocent image and literally reads its new orders from the pixels. It's a completely silent, totally invisible way to control a botnet. So, if the enemy is invisible, how in the world do you fight it? Well, that's where a whole other science comes into play. It's called steganalysis. And this really gets to the heart of the problem for the good guys. I mean, it's one challenge to crack a coded message when you have it. It's a whole different, much harder challenge to find a message you have no idea is even there. The old ways of detecting this were tough. It was like looking for a needle in a digital haystack. You'd have to look for weird visual noise or run complex statistical tests. Basically, a real natural image has a certain mathematical pattern to it, but hidden data looks more like random static. It's a subtle difference. But now, AI is the big game changer. We can now train neural networks to spot those incredibly subtle mathematical fingerprints that hidden data leaves behind. They can scan millions of files in a flash, looking for things a human would never, ever see. And this whole thing brings us to a much bigger, more complicated issue. Because steganography is what you'd call a dual-use technology. It's a tool that can be used for incredible good and for terrible evil. And that creates this never-ending arms race between the people hiding things and the people trying to find them. Think about it. On one hand, for activists or journalists living under an oppressive government, using regular encryption could be a death sentence. It screams, "I'm hiding something." But being able to hide their messages in a family photo, that could be a lifeline. It lets them communicate and organize safely. But then you have the other side of the coin. That exact same power lets criminals and hackers operate almost invisibly. The tool itself isn't good or bad, but how it's used definitely is. And this quote really nails the challenge we're facing. We are just entering an era of dark data. With the explosion of the Internet of Things, billions of smart cameras, sensors, you name it, all creating massive amounts of media files, the number of potential hiding spots is just blowing up. It's growing exponentially. There is just no way to analyze it all. We're swimming in this ocean of dark data, and honestly, we have no clue what's really hiding inside it. So when you think about it, for decades, we've been focused on building stronger and stronger locks. That's cryptography. But steganography doesn't even bother trying to pick the lock. It just walks around and uses a hidden door no one knew was there. Which leads to the final question, doesn't it? In this ongoing war for our digital security, what's going to win? The strongest lock or the sharpest eyes?